Hello, this is Naz from NB Network Lessons. Hope you guys are doing okay. My today's topic is DC circuit analysis, lesson number 18. I do have the diagram right in front of on the board. So we've got a transistor right here, and as you can see, the arrow is pointing out towards the outside. So right away, I know this is a PNP transistor, right? And I sub B is going to be going in this direction. So what we've been asked is primarily to find voltage drop across VCE right here. That is what I have been asked to do. So the VCC is 24 volt. It's grounded right here, and then you've got transistor, and you've got this transistor surrounded by resistors. We need to find I sub C, I sub E, I sub B, and then we finally need to find V of CE, voltage between collector and emitter. Now, when we solve DC circuit analysis, when we do DC circuit analysis on transistor, there are some assumptions also taken. And these assumptions are pretty accurate, okay? So I'm going to be using some assumptions in this particular problem. So the first assumption is that you can assume that if your R2, which is the resistor right here, okay, is less than 0.1 times beta, which is the gain, times RE, resistor at RE. So if this resistor value is less than this right here, we can assume that there is no base current to negligible base current going in this direction. So let's see if we can find that out. R2 is, I know it's 30,000 because it's 30K, less than times 0.1 times beta, which is given 150. Beta is the gain. Always remember that. VC over EE. 150. And then RE right here is 3000. Okay. When I do that, I get 30K. And on the right hand side, I get 45K. Okay. So then I can assume, since this, based on this assumption, I can assume that I sub B, excuse me, then I can assume that I sub B is almost 0. Okay. Work further, and let's see if we can find voltage drop, V sub B. Okay. So how would I find voltage drop? Voltage drop right here. Okay. So I can apply the voltage divider rule. If you recall from your circuit analysis class, voltage divider rule, if I apply that, I can say V sub B, voltage at this right here, is equal to the voltage, which is right here, 24, which is the voltage is across the whole thing, 24, times 30K, which is this resistor, over 30K plus 130K. This is the voltage divider rule I just applied, okay? And if I solve this, the answer is 4.5 volts. So now we know V sub B is also 4.5 volt, okay? Now, let's find out, we still need to find out I sub C, I sub E, VCE, voltage. This is what we have to finally find out. So now what I am going to do is, remember I told you that there are some assumptions taken, okay? If you recall, when we were discussing semiconductors, diodes, I told you that in order to activate a diode, okay, put it in active mode, you need around 0.7 volts. Remember that? Yes. So I'm going to use that assumption basically and say that voltage at emitter is going to be, this voltage at emitter is going to be 0.7 volts less than V sub B. So we already found what V sub B is, 4.5. So under that assumption, V sub E, voltage at emitter, is going to be 3.8 volts, right? Okay. Now what we do is that we make, we need to find I sub E, okay? We already know what V sub E is, so we need to find I sub E. So I sub E is equal to V sub E over this resistor 3K, which is R sub E. So if I solve that, I get V sub E is going to be, I already know, I calculated it, 3.8 volt. 3.8 divided by 3K, 3000 ohms. And if I solve that, I get 1.26 milliamps. Okay, we're making progress. Okay, we have I sub B, V sub B, V sub E, I sub E. Now let's make an assumption, another assumption. And that assumption is that I sub C, collector current, is almost equal to I sub E. Okay, we can make that assumption. So then I know then I sub C is also equal to 1.26 milliampere. Now these are the characteristics of the silicon which we use, and using those characteristics we can make the assumption that IC and IE are almost same. Okay. Now we need to find, finally I have everything now in order. I just don't have the VCE, voltage drop, right here across collector and emitter. So if I think about it, voltage at collector emitter is going to be 24, right, minus voltage drop right here across 8K, voltage drop across 3K. Okay, so the voltage drop across 8K is 10.08 and the voltage drop across 3K is 3.78, and then the answer I get for VCE is 10.14 volt. So how's that? If you have any doubt that how I got this 10.08 voltage, you can do V is equal to IR. V is equal to IR. So in this case then we just do this on side. V across 8K resistor is going to be 1.26 milliamp. I calculated the I sub C right here, times 8K. So if you calculate that, you will get 10.08, 8 volts. So that is it, my friends. Quick and easy DC circuit analysis. Watch this video maybe a couple of times. It will make sense to you. If you have any questions, send me a message. I hope you liked it. If you do like it, I would encourage you to share the knowledge. Share the knowledge as much as you can, because sharing is caring. Thank you so much for watching. Have a nice day.